The Nobel Prize. What is it, you ask? It is a very big award, a huge honor. It is given for amazing work that truly changes our world. Think of the most famous scientists. Many of them have won this prestigious prize. It shows us the incredible power of human curiosity. This year, 2024, the Physics Prize points to a new revolution. Who won this year's coveted prize? Two absolutely incredible minds. Their names are John J. Hopfield and Geoffrey E. Hinton. They are the 2024 Nobel laureates in physics. They didn't peer through telescopes at distant stars or smash tiny particles together. They looked at something else, something fundamental. They looked at how we think, how intelligence works, and how machines might, one day, learn to learn. What was their monumental prize-winning idea? It's all about artificial neural networks. That might sound like a very fancy term. It simply means making computers learn, much like our own brains learn from experience. Their foundational discoveries made this possible. They invented entirely new ways and methods, ways for machines to understand complex patterns. This is the very core of modern machine learning, truly groundbreaking stuff for all of humanity. This prize is a tremendous honor, a global recognition. It also comes with a significant amount of money, 11 million Swedish kroner to be precise. Wow, Professor Hopfield and Professor Hinton will share this amount equally. But the real prize, the lasting prize, is the recognition. It triumphantly tells the entire world, this research matters. Physics helps us understand the universe in all its forms, even how to create a new kind of intelligence. A new kind of intelligence born from silicon and code. Let's journey back in time. Let's meet John Hopfield first. He is a brilliant professor at Princeton University. Back in the year 1982, he had a powerful vision. He wanted to build a special kind of network, a network that lived inside a computer. This network would act very much like our memory, not just any old memory like a shopping list. It would be an associative memory, linking ideas, remembering things that belong together, interconnected. He called his fascinating invention the Hopfield network. Picture many tiny digital dots in your mind. These dots are called nodes, like tiny brain cells. They are all connected to each other intricately, like a vast, complex spider's web spun with logic. These nodes talk to each other constantly. They influence each other's state, their activity. This remarkable network could store various patterns like pictures of faces or familiar sounds or even words. It learned them deeply, embedding them in its structure. How did this network perform its apparent magic? Professor Hopfield cleverly used principles from physics. He thought about energy, a core concept in physics. Like how magnets naturally find their lowest energy state, the Hopfield network always tries to find its calm state. This calm, stable state, a memory, a stored pattern that it has previously learned. So if you give it a fuzzy, unclear, or incomplete image, it works to clean it up, to complete it. It finds the closest, most complete memory it holds. This was a truly massive step forward for science, a profoundly important step on a long journey. It showed something absolutely amazing to the world. It showed that many simple parts, working in concert, could perform remarkably complex and useful things. They could store vital information effectively. They could retrieve that information when needed, even if the input cue was not perfect or clear. This was a key insight for artificial intelligence. It was a fundamental building block for thinking machines.